Okay, this is example 2. We are given parallel lines and that is it. So if I look at my similarity theorems, I am not going to use side, side, side because they gave me no sides, and I'm not going to use side, angle, side because they gave me no sides. So I have to show angle, angle. Okay. If I look at my diagram, one angle that I see is vertical angles, so I can use that. That's one angle. And then part of our notes from class, one of the things we've talked about in my class especially, is that anytime you're given parallel lines, they're trying to give you a pair of congruent angles. Because if you have parallel lines, then the corresponding angles are congruent, the alternate interior angles are congruent, the alternate exterior angles are congruent. So for these proofs, they're always trying to give you parallel lines. Or sorry, for these proofs, if they give you parallel lines, they're going to give you something congruent. So we're going to start with parallel lines. AE is parallel to CD. I'm not going to highlight the triangles because you can see the two triangles, ABE and DBC. So if I have parallel lines, I need to choose which other line I want to be my transversal. And it could be either one. I could either use EC as my transversal, going all the way through, and show some angles there. Or I could use AD as my transversal and show those angles. Either way, it's going to be alternate interior angles. Now I already have it typed up, so I don't remember which one I used. I said E and C are alternate interior angles. So that means that I used that one, CE. I'm talking about angle E and C. So I say that angle E and C are alternate interior angles by my definition. I then say that E and C are congruent from the alternate interior angles theorem. So now I have one angle. Then I have to show vertical angles. So I identify my vertical angles, ABE, that's this angle, ABE, and CBE, that should be CBD. CBD. Those are vertical angles, definition of vertical angles. If I have vertical angles, then I have congruent angles. So ABE and CBD. And now I have two angles in one triangle, congruent to two angles in another triangle, and that's my angle-angle theorem. Angle-angle, if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. That's exactly what I showed here. So as a reminder, example 2 is really good to remind you that you can use vertical angles. Vertical angles are a two-step process, and that you can use parallel lines. Parallel lines are really a three-step process. Identify the parallel lines, state what type of pair you're going to use. I'm using alternate interior angles, and then use the theorem to say they're congruent. Final step, triangles are similar because of angle-angle.